Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg in a celebratory mode here today.
And this is Kirk Gray.
So congratulations, Kirk. We were chatting earlier, and you're right at or very close to your 10th anniversary for your book. And it was on HALT and HASS : something.
The title is Next Generation HALT and HASS: Robust Design of Electronics and Systems by myself and John J. Paskowitz.
Yeah.
John is retired. I'm still active, but even though I'm semi-retired, but I still do consulting. And I'm really amazed. I'm really surprised, and I guess not surprised, because I wrote the book for knowing that technology evolves very rapidly, that there will be different, possibly, we go from through-hole to surface mount to flip chip to, it's going to continue to evolve. But the one thing that's not going to change is fatigue and fatigue damage and chemical reactions, abuse, things like that are not going to do, and manufacturers losing process control after you've already built a robust design. Any robust design can quickly be a very weak and problematic system if one of your many tiers of the supplier chain loses process control and is not aware of it in particular. So, I wrote this book as basically a frame to encourage looking at the problem of reliability, early product reliability development from a different frame of reference. And that is from the strength of materials and the intrinsic life of materials, of components, especially silicon, and every component in resistors, wire wound resistor, every kind of component has very significant life. And our past podcast talked about how technological obsolescence generally comes before the end of life. So, before the product wears out. So chips or components ever fail because they're used up, and now they can be manufactured poorly and they have flaws in them, and those are we call latent defects that may end its life early, and we certainly all had cases of that. But that generally occurs very early, within the first 2 or 3 years, and after that, if it's running, that's why buying an extended warranty is really a bad bet on any kind of home electronics. That you have plenty of life. Now, the mechanics I treat separately, and I do address that you can do a wear out test with mechanics, like windshield wipers on your car or something like that, where you can actually do periodic measurements of the material worn off and make a model of how many wipes that windshield wiper but just look at, another car component. Look at the problem of trying to predict the life of tires. They say 60,000 miles is, a guarantee or warranty.
That's because 50,000 wasn't any good anymore. I don't know why.
Yeah. So I'm just thinking the problem with these guys trying to predict what is this going to be, if you think of all the cars and all the different kinds of road surfaces
and
across the world.
Styles of
drivers, types of cars, torque of different cars, weight of different cars. How can they make these claims? Where do they make, and how do they make these estimates? Because it's thousands of models would have to be used to, gravel versus a dirt road versus,
that they run it out over, how often do people have, watching the wear of their tires and they get it replaced, and doing surveys of shops that do tire replacements, you can measure the tread, and,
right,
and the mileage
guide, right?
It's kind of I don't think the data is easy to get or clean.
No.
The telemetry stuff we're getting off of some cars these days is going to help a lot with that. But the idea is that I'm sure that they had a bunch of surveys and field data, and I don't think they tested it to figure it out. But what I don't know and what they don't talk about is they might have been using MTBF. All right, we got data on 1,000 vehicles, and on average, they ran 60,000 miles before they had to be replaced. But they completely ignored the variability part, whereas some
Mm-hmm.
people drive and in horrible conditions and horrible stresses on the wheels and
Right.
hard stops all the time. And they had 3 teenage kids that were seeing how many skid
I'd
marks they
like
could make.
love
And
to, yeah, love to leave skid marks on the
yeah,
pavement. Yes.
that's not normal driving, but that one probably got changed out at 20,000 miles. And others, are run very lightly on really clean roads and very light vehicle, and they run for 2,000, 20,000 miles before,
Right.
or, go 80 to 100,000 miles before they're in need replacing.
Right.
It's the claim of a single point, and that's been what I wanted to celebrate. When you mentioned your book's 10 years, I'm thinking, oh, I think nomtbf.com is at 15 years.
Yeah.
And you've contributed articles to it.
Right.
And,
Right.
and we had some friends over on Sunday, two reliability engineers. So my wife had to, um,
Listen to a bunch of
listen to shop talk
stop
there for a
talk.
while.
Oh my God. Diane, my sympathies to you.
But we talked about all kinds of stuff, and the topic of no MTBF came up, and both these two younger generation engineers were like, "Oh, I know about that. I heard about that. I recommend it to people all the time." And I don't know. Have you heard feedback like that on your book? Oh, I recommend Halt because of this. We found these successes out of it. Do you get feedback at all
Well,
like that?
yeah, I mean, if you look at the reviews on Amazon, I've got I think 11 reviews of
Mm-hmm.
5 star, maybe one, and the guy that did 4 stars didn't ever write anything, but they're almost all 5 star and talk about how this is very comprehensive, and that's what I meant it to be,
Yeah, yeah.
is not only what the theory is, but how to apply the methodology, and that it's extremely adaptable. And that's what I wanted to focus on, that I can't make, this is what you do for a circuit board of 8 by 10 with 1,000 components on it, or
Yeah,
things like
versus one
that.
that's
Yeah, and and also your system. But I can tell you that when you pull a circuit board out of most systems, you can't tell what it does. You don't know if it's a DC
well,
or biomedical or whatever, but they all look the same. You use same solder, except in the oil instrumentation and oil
or under
rigs
the
or
hood,
oil
under
or
the hood
under the hood.
electronics.
Right, right. But those are, look how robust they are for our electronics in our cars, because they have the worst environment you can have, especially here in Colorado, especially if you're in Leadville at 11,000 feet. You know, you can have some dramatic temperature swings here. And we had one the other day. It went from 71 day to 30 the next. And,
Oh, yeah.
because our air is so dry,
Thin, yeah.
the heat capacity of the air is very low, so it quickly can change temperature. But regardless, the in general, components and circuit boards are pretty extremely robust when you test them to the limits, and that's what I encourage. And then using that strength, operational comparative boundaries. In other words, comparing the limits between samples and between, when we talk, I think you talked about it recently, about comparing vendors. If you're going to
Yep.
choose between two power supply vendors and they're the same price, I definitely
Right.
would go with the one that has more margin on it
Oh,
in
yeah.
thermal and vibration,
Right,
both.
right. But what I'm getting at, though, Kirk, is you started this and it was part of, getting in the market and helping people understand what Halt is and why it's
Right.
useful and all that other good stuff. Have you seen that turn a corner yet or not? Are you getting reviews, but are you getting people that go, may not have left your review, but have you heard from anybody that said, oh, this is what we needed and this has made a difference for us. Or I refer your book to everybody I talk to, or,
No, there was one comment on the post I made on LinkedIn about, suggesting to somebody else
mhm.
in the connections that they ought to use this book. So that's the best I can get.
All right. Well,
A lot of times,
give it another 5 years, because I'm getting. I ran into a professor, a mechanical engineering professor, and she said she makes. I think there was 10 or 15 articles on the site, on the No MTBF site, that are required reading for her engineering students.
I hope that's true. I'd love it to be one of a required reading my book for a class on reliability because I
Hmm.
think it definitely. My whole point was to give a different frame of reference over traditional reliability engineering that was mainly focused and has been on reliability modeling and reliability prediction,
Right, but
which I say
you're not getting a flush of sales at the start of semesters, are you?
I'm waiting for that. But my sales did increase last year, so it may be catching on. It may be
It's an
to see
overnight
an
10-year success.
yeah, it may be. I mean, that's what we know of those stories.
Yeah, yeah.
So yeah, once it's like this is not working, and one of the recent attendees to Rams, I don't know where he posted on LinkedIn about his visit to Rams this last year,
Hmm.
was about how they're using 40 and 50-year-old uh, theories for today. And he was complaining about that. And I said, well, yeah, that's, that's why I don't go to Rams. I don't go to
Well,
any of that.
but we also talk about manufacturing process control and stability and stuff like that. Control
Right.
charts were invented 110 years ago, and
Well, and
you
then
can
them
still do
in
them by hand, and I prefer it that way. As soon as you automate it, nobody pays attention to it anymore.
right. We saw the SBC and all that. It
Yeah,
was a
but
it,
that's it when done well, not just a showcase thing, but when done well, it's great. And I think HALT is a different perspective. Rather than saying, oh, I passed all these standards, which we've talked about I don't know how many
right,
times as being pretty
right.
meaningless. I found out where it fails and I made it stronger. I made it more robust. Is a
Right.
whole lot of let me get my English teacher riled up here. It's a more better approach.
It's a more better approach. And I think that those people that use it and do try and, go outside the box, which is literally the specifications box
Yeah, yeah.
that it's tied to, and try different things, combinations of voltage margining and thermal stress, or
Well, what's appropriate for your whatever
yeah,
product system
whatever
is.
product,
You
right.
got to think through it, and that's the gist of it. Now, here's another thought for you: is you've ever had anybody say, "But we don't do Halt because I can't get MTBF out of it."
Well, yeah, I mean, right. And
I mean,
I
is that a pushback that you've heard from people? Because if
well,
not, then
yeah,
it's
we need a
because
number. We
the
need a
no
yeah, what is
we need a number.
yeah, what is this equivalent your time in the chamber? What's that equivalent to the field?
Not.
No, no, I'm not. What's the MTBF? Well, I'd point them to your website,
Ah,
nomtbf.com.
see, it works.
Yeah, I said, yeah. In fact, I see this because it's still a big topic in LinkedIn, in the reliability groups. You see it mentioned all the
All the time,
time.
all the time.
And I'm going, my God, when are we going to get out of this? Fred started this, what, 15 years ago.
I get
And
copied on some of those. Let's see what Fred has to say about this. I get one of
yeah,
those about once a month,
exactly.
and I
Right. And whether
give
you're
him a
just tired
rant.
of commenting, which,
Yeah.
which we all are, but, I mean, I, I've been in this business, 30 years or more. I can't even count now. And I started out working on equipment. I was repairing and servicing equipment, and then I evolved to testing, from field service engineering, complex
Hmm.
equipment. So I kind of knew how to troubleshoot, I knew what the capabilities. But, I mean, I was working on ion implanters with 200,000 volts.
Don't put your
Okay.
finger there.
Yeah. Don't worry. You won't get close to it. It'll get close to you first.
It
It jumps
likes
to
you.
you.
Jumps
It
to
likes
you.
you. It's called lightning.
Yeah,
Anyway,
and you're grounded. Yeah, you're such a
yeah, yeah,
grounded person.
exactly. But you can't, those were things I couldn't margin test. You couldn't margin test even if I knew and went back to that, that was in the 70s and 80s. but now, they're so the but the subsystems you can test, the subsystems,
In the control circuitry, all kinds of stuff you can play with on those.
and
Yeah.
I know that you can also come up with a formula of margin versus reliability if you have past products, and you knew what their margin was. Ed, a guy from Cisco Systems wrote a paper about that. That you could use a best fitting curve, and you could show a monetary cost to increasing the margin on a product.
Oh yeah, I ran into that with a handheld.
Ed
The
Kaiser. Ed
Yeah,
Kaiser.
yeah,
If you look up
yeah,
that, Ed
yeah.
Kaiser
Ed Kaiser
was with
is the right
Cisco,
guy.
and he was very, very good about the mathematical approach to it.
Well, there is a guy. I told you about this one. It was the handheld barcode reader that they use for loading luggage, recording luggage loaded onto a plane or taken off a plane.
Hmm.
And they had a drop test, and they thought, oh, the 10 feet, three times, and that'd be good enough. They
Hmm.
ended up showing the relationship that every time they increased it and the number of drops, their warranty went down. And it was just a perfect fit. And so they ended up being as tall as their two-story building and dropping it, I think, 100 times before it
Right.
was ready. The design was certified then to say we're going to ship it because
Right.
they had this direct correlation to reduction in warranty expense. And so
Right.
they were able to do that math and say, all right, got to make it solid.
Yeah. And one of my first articles for No MTBF was no correlation. That there was no correlation in the mini prediction handbooks and what comes back from the field, from the actual failure modes that
Oh
come
no,
back from the
there's a
field.
paper. I think I listed and I had an article similar to that, but it
I
was
go,
based on a technical paper by, and I'm drawing a complete blank on his name. He was a professor, engineering and reliability type stuff in England somewhere.
yeah.
And what he did is he got a bunch of students that their project was they got in teams and one did the reliability parts count prediction based on Mill Handbook 217, whatever it was. So
Hmm.
there's a
Hmm.
Telcordia one, there was a French one, there was a
FIDES,
Japanese one.
FIDES. Yeah,
So they
there's,
use all these various
yeah.
methods,
Hmm.
and they had a small circuit board that the
Hmm.
professor had the actual field data for, and it was in such a system that they would get really good field return data. But it wasn't perfect by any means, but it was pretty darn good. He had high confidence that they were getting an accurate reflection of what the field data was because of the nature of the product and its servicing and stuff like that. And
Hmm.
so he knew the field answer, and he
Okay.
was curious of, if we have three different people do 217, do they get the same answer themselves? It's the same exact circuit board. It only had like 120 components on it.
Right.
And then there was different systems. So they had all they were checking the same
Yeah.
system against itself by different people, and they were checking different
Right.
systems against the other ones.
And let me guess, the predictions were all over the map.
Yeah.
I mean, the deviation
They were
was
plus
incredible.
200% to minus
Right.
600%, or vice versa. I don't remember which, but it was
Right.
one of
Yeah.
them was close, and you think that was just random because they had like 20 different scenarios or what they were doing.
Right. Right.
And it's like, yeah, they're just all over the map. And the
Oh, come on.
variability from one person to the next using the exact same system, the exact same process to do it, got completely different answers. And it's like,
Yeah. Yeah, it's just that's the silliness to me of the prediction area, and unless you're talking about like we talked about with you know tires of an automobile, and you're making averages about things or predicting averages, but
who
for
cares
the
about the
most part,
average? What
yeah,
about
who
my
cares?
car?
Exactly, but the whole point of my no correlation article, and maybe I'll put a link in the notes, but was the fact that all the things that are in the models, like temperature especially, that for every 10 degrees C, this was in the past, I don't know,
Yeah,
it
yeah,
maybe
yeah. No, I
well,
saw
it
that in
hasn't
a
been changed.
discussion the other
Every
day.
10 degrees of C, the
Life would get double or cut in half or
no,
whatever
no,
it was.
right. It would cut the what did it call it? The failures in time fit rate. it would increase the fit rate by 50% for every 50 degrees. Whatever. And they don't know what the failure in time rate, and they don't know what the life of components is, because nobody can run a semiconductor product till the end of its wear out life. I think what a CPU, if we had a 386, Intel 386 right now running, I'm sure it'd run. In fact, we've got plenty of computers that we could boot up for that old chip that was 30 years old. It's probably still got, we don't know what life we have in components.
Can you imagine
We
how
don't.
many Microsoft updates you'd have to put on that 386?
And just think how long they would take.
Yeah.
Yeah. It could
And
be
then
days
that would
before
wear it out.
Yeah, exactly. So that's the
There's
problem.
the stress test is you
Yeah,
have them do
exactly.
the operating system updates.
The programming has gotten much more, as the power of hardware has got increased, the available the programming has increased, and we like it that way. I was sitting in front in the University of Texas with a little green screen and acoustic coupler,
Yep.
and it would bring out little lines of green text. And the most secret thing, or the things that guys tried to do in my electrical engineering class, was go play Star Trek. Now, you wouldn't. There was a bunch of dots on the screen with, letters in a matrix, square matrix, that would represent the Starfleet or whatever. And it's the most incredible. But every guy, and there were some women that had a chance, even though it was illegal or against the rules, frowned on, would go in and try to boot up this, why they left the Star Trek program on the mainframe.
Well, it got you in the lab.
They would occasionally get you in the lab, and somebody showed it to me. And I just think now, if you look at our today's gaming systems, they're photorealistic. They're movies that you're interacting with. They're so deep in.
Well, I saw it the other day, was that the video game industry, it's 10 times bigger than television, or like TV shows, whichever format we get them in these days, and movies combined. It's like 10 times bigger than Hollywood in associated industry.
Yeah, and we had the Xbox. I don't ever play it. I never used it because I was thinking, well, I got a PC and it can play everything I want. It can do all kinds of other things too, like read the news.
I need to send you some projects for the website. Write more articles. What are you doing?
Fred, I'm doing this.
There you go.
We're all doing this with no compensation whatsoever.
Hey, you told me you got a little check coming from Wiley for your book, so.
Well, I say not from this podcasting.
No.
I'm getting, that's what my hope is, that people will buy the book, because it's always at the bottom of my notes. But I think it's amazing. I listen to lots of different podcasts. Most of them have endless streams of ads. Very difficult to listen to because, well, fortunately, you have a fast forward. But, people don't realize that everybody on these podcasts has no compensation other than, being able to talk to a reliability audience, which I enjoy doing.
The greatest joy is you walk into a conference or in a group setting, and I was in one where I didn't know that many people there at all.
Yeah.
I knew a handful of people. I'm sitting at lunch, and somebody across the table says, "Wait, I know that voice. Do you do a podcast?" It's like,
yeah. I told you open your mouth, right? They've never seen you.
No, never saw me.
Although your picture is, you probably changed. I've changed. I know. I'm using a 15-year-old, 20-year-old picture.
But you put your picture on every episode. I don't do that. I don't have my picture with episodes.
I know. I like them to see who it is, but yeah. And we don't do a live, like a lot of people do podcasts that are live.
Camera and two people talking into microphones. Right. That's exciting.
Well, it depends. It depends on if you like the way they express, and they can. I think there is a lot of visual information from.
Oh, I wave my arms all the time with you.
Yeah, they can't see it, right? But so yeah, the book and your site. Of course, we met in San Francisco. When I saw the no MTBF sign, I said, "Oh, this guy
must be Fred.
Here's a rebel. Here's a rebel." MTBF is the holy grail of all reliability prediction, and
Oh,
here
now
he
bite your
is.
tongue. Now there is hope. There is hope. The two younger engineers I was talking to this weekend, and they said they when they were learning reliability engineering, either on the job or in school, is they did not know about MTBF. That wasn't part of anything they learned. And
Oh,
it was part of it
good.
was where they were working, I think. And
Yeah.
so they ran across it somewhere and says, "What is this?" And they look into it and they're like, "This doesn't make any sense." And so it was, geez, we got to get more people on your guys' career path and education system because it's still out there. But there's
Right. It's
progress.
great that they were never contaminated with that kind of belief and averages like that. And
Yeah.
you know, it's just it's it's just amazing that it's still just like prediction. And 20, 25, 30 years ago, Michael Peck was writing an article, Why Traditional Reliability Methods Don't Work. Is there an is there a change? That's something and that's kind of where we connected 20 or 25
Mm-hmm.
years ago, with also Vijay Dasgupta coming to storage technology, which doesn't exist itself anymore, and coming to see what we were doing with Halt and Hass. And of course, Greg Hobbs was there at the time. And so I kind of made an inroad there with Boeing called it reliability enhancement testing,
Mm-hmm.
RET. And then I don't know what's happened to it then. I kind of feel like people like one of my employees at Storage Tech, Simon Prakash, who went to Apple and became a director of reliability.
Well, then he went
I
to
mean,
Google and got promoted like 10
Google,
more
right.
times. Yeah.
He's an excellent. I was really impressed when he was there, and he was always just a great communicator, and I encouraged him to go make presentations and things like that. But I'm sure he's doing well, and I imagine he's somewhere, if he's even has any touch to the reliability group, suggests these methodologies.
Yeah. But I think the gist of it is that, there's good stuff that can be done and there's stuff that's not in your standard 50-year-old textbook. And we've been pushing different messages and trying to enhance our world of reliability engineering. And there's plenty of
Hmm.
signs that, yeah, it's working. It's making a difference. And so it's like you said, it's not like everybody that reads it know MTBF. I get $1 million. That would be nice, but I don't put the ads in there. I'm not. I mean, I sell coffee cups through some online
Yeah, I'm
the
sure you're
internet.
making a
No,
bunch of
no,
money on that.
it's at cost because they
Yeah,
were already expensive enough. Because
right.
so I was like, I'm not going to make any money on this. I'll just give them away. But the idea is that you can make a difference, and sometimes it takes a while, and sometimes you have to have your homework right, that kind of stuff. But it's don't just do it because that's what everybody else is doing. Do it because it's the right thing to do for
Right.
whatever your circumstance situation is. Yeah.
I remember Dr. Andrew Kleiner when we were at Rams, I
Mm-hmm.
think, or AST, Accelerated Test Testing. He reached over and he was the editor, and he's for Wiley and Sons,
Yep.
tech quality. He looked at me, he says, "You're cutting across the grain."
Yeah. This is tough.
Well, that was my intention. I don't want to be another Me Too. Hey, FMEA, all those things I talk about a little bit. And John Paskowitz, who wrote a lot of the chapters in the back of the book, shows some modeling, shows some ways to do ALT. And
Mm-hmm.
I was okay with that. And he made sure that people realize this is very limited to what you can apply it to. But it is valid for some in the cases that he made.
Mm-hmm.
Uh, but for the most part, most of the book is trying to be a change agent to the industry. And just like Greg Hobbs was before he died in 2011, I think.
Yeah. Well, we'll have to chat again in another 10 years and see how many, how much more different the
I don't
industry is
know if I'll
doing.
be doing that at 781,
Why
Fred, but I
not?
might.
Yeah, you're still earning enough.
Yeah.
You'll be fun to talk to.
Well, as long as I can play pinball, we'll be
There you
fine
go.
with that.
Very
Okay.
good. All right. Well, anyway, good chat and congratulations again. And hope
Well, thank you.
the
I
sales
hope it sells
continue to grow.
another. Hope it goes another 10 years. But I know
Yeah,
at some point,
you got to do
maybe
an update to it. Do the revision to it.
vision. I yeah, but I kind of tried to. quote, future-proof it if it could,
Yep.
whatever, knowing that I wasn't going to update it and the technology was going to change, and it's stressing and wear out and fatigue and
That all stays the same.
variations going to stay the same no matter what technology is at the time. And it's great that it's becoming, all the electronics, especially our phones, are becoming much more robust, whether it's because of my book or us talking, or other people suggesting go to the limits.
Yep.
Stress to the limits.
Well, I think we're at our time limit here, Kirk, so we'll have to wrap it up here. So if you've got questions for us, if you were interested in contributing to the nomtbf.com site, that'd be great. We've got to get that going again and get the word out more often. And if you haven't got a copy of Kirk's book yet, Kirk will put a link below.
Right. Absolutely.
On the site. And so pick up a copy and enjoy it. And then send them a note saying whether it worked or not and what issues you're having. And those can become future episodes for us of praise, or
we'd love to hear
the struggles with it. Let us know.
Yeah. I especially like negative feedback, because that helps me improve things. That's the only way. I love hearing. You want
a HALT test. That's what you want. You want to be.
Yeah. What limits have you found in your company in pushing these ideas?
Right. Yeah. But you can get in touch with us over at accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us there. Kirk and I and the others are available through LinkedIn and our About pages. So if you want to apply some stress to Kirk, send him a note.
I love it. Yeah. Test me.
That's right. There you go.
Test my limits.
That's right. Yeah. It's like, well, I'm not going there. There'll be a whole other episode. Okay. All right, Kirk.
We'll talk again.
Cheers, Kirk. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.